many of you know, we recently closed the applications for the WILDLABS Awards, and you'll hear some statistics from that process during our ad break later, which are very interesting. But we thought we would have a bit of an awards theme for our speed talks this month, where all three of the speed talks were actually funded through the WILDLABS Awards or the Boring Fund at some stage. So for our first speed talk, we'll learn about open source camera trapping infrastructure from Izabela Stachowicz. Then we will learn about GPS tagging of noctule bats with a talk from Lucia De La Huerta and Edward Hearn. And then our third and final speed talk will be from Matthew Duggan, who will talk about FinDrop, which is a deep water marine acoustic recorder that they developed. We'll then go into our usual ad break, where we will include some statistics on the awards applications before we do our regular quiz, which we know everyone loves so much. And then our final talk is unrelated to the awards and will be about the newly launched Wild Moves and Wild album by Francesca Cagnacci and Peter Desmet. So that's everything from me. I would now like to hand over to Izabela, who can take us into our first talk. So please, Izabela, go ahead and share your screen and take us away.
Thank you very much for the invitation. It's great to be here and talk to you about the Trapper Keeper, the scalable open source camera trap infrastructure. So it is a project that was awarded by WILDLABS last year. And we had a chance to create an amazing group of people, software and hardware developers, researchers and conservation practitioners who work on daily basis with camera traps, technology that have changed biology and conservation field for good. And I think that I don't need to really talk a lot about it. So we, a group from Open Science Conservation Fund, Variety, Universidad San Francisco de Quito, and San Diego Zoo Wildlife Alliance. So we aim to benefit the conservation technology community first by reducing waste of development, by consolidating efforts on a single collaborative open source camera trap application of this Trapper, and then improving usability and scalability by providing blueprints for energy efficient, low-cost servers that can be used by both small local groups and large-scale web services. So yeah, we dreamed having some small edge device that will help us process data in remote areas where electricity and internet are scarce and where we are working. So yeah, a little spoiler alert, yes, we did it. So to give you some background about Trapper, that has been constant research and development process since 10 years. And with WILDLABS Award, let us make another step to stabilize and upgrade Trapper to upcoming challenges and in data processing. Trapper has multi-user and role-based structure that facilitates collaborative work on camera trapping projects among researchers, NGOs, and empowering citizen scientists. The platform has been already used across different institutions in Europe, and it's getting also attention in South and North America. So there are two interfaces available through which you can upload data, citizen science, offering a streamlined, user-friendly experience for quick, basic data management, and expert, providing advanced tool and customization for researchers who need detailed data processing and in-depth analysis. So just let's look what is going on with those red deer jumping here with the we can change bounding boxes, change identification with AI that it's making, of course, mistakes, fortunately, still. And it gave the interface, it's really friendly, and it was very important for us to make a video available also on Trapper, not only pictures. So after uploading videos of pictures through interface, it got to different server options. So Trapper can be deployed on servers like cloud, local, like bare metal servers, then the servers that actually put in the suitcase, the one that you could see in Peru on WILDLABS conference that was in ARM booth available, running Trapper actually. And also you can deploy Trapper on laptop and on edge devices like Raspberry Pis. So the infrastructure is based on Docker containers, runs on different various processors architectures, but the ARM is the most common. Well, we can use Raspberry Philo accelerator, and which can give us really good results in these remote areas, like it was already tested in Peru itself. So the next step is that Trapper integrates AI tools like Megadetector for automated detection of animals, humans, vehicle, and empty frames, alongside supports for custom species specific models such as Big Fauna, ADAX, and models that we have created in this project with San Diego Zoo by Kira and Alvaro for species from South and North America. So additionally, the platform provides robust human annotation functionalities to provide high precision data validation. Yes, AI is not perfect. So if you already like Trapper, it's a good news. You can install it on your own. It used to be very challenging to set Trapper, but we have right now these nice tools, Trapper set up to do it, and we are developing documentation to make it easier than to process. Later, all data goes to Trapper DP standard that Francesca and Peter will tell you more about. That was an effort of 35 researchers from 32 institutions to actually create this standard. And we, as within the project, we are connecting Trapper with GB integrated publishing toolkit to enable one-click publication of standardized CamTrap DP packages. So it was great to see that this award gave us an amazing kick to go out of our comfort zone and look for commercial partnership for Trapper development, as happened recently at Canonical. So if you liked what you saw with Trapper and you are interested to join our effort, as Open Science Conservation Fund and Variety, we are looking for volunteers and people interested in working with us developing this open source project. So please contact us through Slack that you have here, or look at our website, or write me an email, and we will be really happy to see how we can make this project running. Thank you very much.
Thank you so much, Izabela. Yeah, thanks so much to you and your team for your talk and just for building such an amazing and such a useful tool. It's really great to see it at the conference in Peru as well, and cool to see that you've got data from Peru as well already on there. So yeah, that was great. Thank you very much. Do we have any questions for Izabela before we move on? Please raise your hand or write them in the chat. Okay, well, if you do have any questions, then yeah, please ask them in the chat, and then Izabela can go and answer them and yeah, give you any information you need. But thank you so much. Our next talk is going to be from Lucia De La Huerta. He's going to talk to us about bats and GPS tags. I'm excited about this one. I'm excited about all of them, but I do love bats. So yeah, this one should be very cool.
Well, in difference with Izabela, I will show more a case study. So yes, we were tagging the lesser noctule and to try to study the migration of the bats from the south of Europe to the north through these miniaturized biologger tags. I'm correcting here GPS for biologgers because actually it gives many more data. So that will be the correct term. First of all, I will introduce the lesser noctule, which is the tiniest of all the 3 noctules that we have in Europe. And it's an intermediate size bat among the 45 species that exist in the continent. And by intermediate, I mean they weigh between 10 and 20 grams, and it can fit in the 4 fingers of the palm of your hand. So bats in the tropics live in the whole year in the same roosts. However, in the northern hemisphere, due to the climate, they need to change among roosts. To do so, they migrate, and some of the species do short migrations, which are about 50 kilometers. Others do intermediates, which are 200 kilometers more or less. And we have another ones that can make about 1,000 kilometers, and here is where our WILDLABS enters. So far, you might think that the most impressive thing is that this tiny animal does such displacements, but the real astonishing thing is that only the females do it. And yes, this is a behavior common among the European migrant bat species. Males are sedentary and females do the long migrations between the hibernation roosts in Southern Europe to the maternity roosts in Northern Europe. However, until recent years, the only way that existed to track the movement of these animals, considering their weight, was through the use of four-arm rings. Unlike the bird ringing, bat ringing has two critical points. First of all, the placement of the rings, being in the wing, interferes with the daily movements and can cause serious injuries. And second, recovery success is really low because of their critical and nocturnal behavior. Accidental encounters are not abundant, and the amount of people actually interested on or working with bats is quite low in comparison. This highlights the need to find other ways to study their movements in this technological era. This gap in the knowledge and technology is something that the Max Planck Institute is addressing through the Europe-wide Icarus Bats project, which is led by Edward and Dina. And in this project, they focus on studying 4 of the long migratory species from Europe, which are the 3 noctules and the free-tailed bat. As you may have noticed, we will be focusing here on the Nyctalus lady only. As part of the project, to improve the methodology to study these species, they developed the nanofox, which are the miniaturized biologger tags, and they weigh 1 gram. They are equipped with the EOT that can connect through the Sigfox network and sends each 3 hours a GPS point, temperature, accelerometer information, and air pressure among the most relevant data. And basically, the data you receive will depend first on how long the device remains attached to the animal, but second, on the battery life. However, in most of the cases, it was more than enough to track the migration, as long always that the device are attached at the right time. And here experience speaks for itself. In our first year participating in the project, we were able to find only 1 animal, basically because of the amount of field work we could afford to do and the time of the year we went. So we missed them for 1 week. However, this is something that, thanks to the 2025 WILDLABS Awards, allowed us to change and to destiny the personnel and the resources to do a well-organized field campaign in order to not fail again. And we aim to tag 20 females. Yes, we jumped to a go hard or go home approach. And to find them, we use the platform of the batmonitoring.org, which is a citizen science project with 5 standardized protocols to study bat populations. It's run from the Vivio Research Group at the Natural Science Museum of Granollers in Catalonia, Spain, which, by the way, is a project and a platform open to all Europe. So I invite you to check it out after. The noctules are species that are crevice dwelling, which means that they can use the bat boxes. Taking advantage of this, from the Kiro boxes protocol, we pre-selected around 500 bat boxes with the species registered among the 3,700 available in the platform. Finally, we revised around 100 bat boxes, finding 42 individuals and ending with 26 female tagged. We made it. To put some context, the whole project in 2025 consisted in 107 female tagged. This means that the effort we were able to do was clearly reflected in a 25% of the total amount of the data for the lesser noctule in 2025, which is amazing. Finally, to summarize our results, I present here, yeah, it works. I present here a quick video which shows the migration routes that we managed to acquire. And putting in numbers, all the animals gave data in Catalonia. 20 of them crossed to France, and 11 of them we tracked for more than 600 kilometers. The furthest point, as you can see, was Hamburg in Germany. Comparing with the methodology used so far, this technology allowed us to have among 40 and 75% of migratory recovery. And here I mean long distance tracks. I want to conclude this journey of empowered females, sharing these two powerful images. In the last 75 years, having among 5,000 permanent ringed animals, all the progress in the movement of the species were 36 records, having only the information of a start and a finishing point. Whereas in 3 years, the Icarus Bat project achieved around 300 animals temporarily tagged, giving all of them information, being able to see stopovers, when they move, how far or fast they can move, and all the data is available at the MoveBank database. This is a step that was so needed to answer so many questions that can guide to better understanding and conservation management of the species. I'm convinced that we have filled a knowledge gap, but in a way, this has raised a lot of new questions for me. And above all, I'm eager to continue studying the movement of other bat species, and I hope technology continues to advance so that we can do this. Thank you very much.
Thank you so much for sharing. That's fantastic. As someone who used to do a lot of bat surveys and do some ringing as well, it's great to see a project that's like adopting new tools to improve the practice and also collect like such amazing and useful data as well. It's really, really fantastic. And yeah, really great to see that final map at the end just being so much more detailed to what we had previously. So thank you so much. Do we have any questions for Lucia from anyone on the project? No, I've got a quick question. Are you planning to run this to do a similar project with more species, or is there any plans in the works for that?
So basically, the project of Edward is studying for 3 other species, but so far we are only involved in the Lessler's bat.
Okay, brilliant. And are the GPS tags still attached in most cases? Will they still be collecting data this year?
No, they last about 40 days, the one that lasts the more. However, this year we started a new campaign of tagging to track this 2026 spring migration. So hopefully I will have more data. So far I did 15 more, so I'm eager to see the results.
Amazing, thank you. We've got a question from Makarand. Please unmute and you can ask the question.
Hello, hi. Sorry, I joined a little bit late. So, with various distribution maps of bird species or bat species, we can see on a map, right? Like for example, Merlin app will show distribution of birds. So, if we are working in a forest area that is, let's say, 3,000 hectares, 5,000 hectares in size, and if we want to systematically survey whether that particular area is a roosting site or a sheltering site or something like that for a species of bats, although a generic distribution at the level of Asia or India might show in a broad brush that the bats do exist in the central India, for example, but whether or not they do exist on a 3,000 hectare land parcel of forest, how can one systematically do a survey of bat species in a land parcel?
So I think Edward may correct me here, which I just saw he's connected, but I think that for studies in little areas, this will not be the correct approach, because the tags allowed us to see long distance.
I'm really sorry. I'm going to have to be extremely rude and interrupt, because I think this is a really good question that requires a detailed answer, but I think we need to jump onto our next call. Lucia, would you mind sending an answer in the chat? No, that'd be that. But yeah, I could just tell. I was like, this is some really helpful information that's about to come out. So if you could maybe message Makarand in the chat. Thank you so much for that question. And sorry for interrupting. Yes, thank you so much for talking.
I'll do it.
Okay. Fantastic. Well, which means we've got time to move on to our third speed talk before the break. Matthew, are you with us? And please, can you share your screen?
Hello, my name is Matt, and I study fish communities on coral reefs using sound. This was our project for the WILDLABS 2024 award, FinDrop, which is about filling a gap in acoustic conservation monitoring. And so the idea started with my PhD focus on deep reefs, also known as mesophotic reefs, which can't be monitored through conventional survey methods, while one of the most biodiverse places on our planet. One of the most effective ways we study these ecosystems is through sound. Reefs aren't silent, as a majority of fish and other organisms produce distinct acoustic signals, yet till recently, most of the focus has been on whales and dolphins. And so, for example, you can hear hundreds of sounds a minute just from these little fish called damselfish on the reef. And so here you'll see an example of the power of sound and the behavior recorded of a damselfish. And so by recording these soundscapes, we can monitor biodiversity and behavior over time without needing to be physically present. But the technology to do so is expensive and, well, sometimes requires a submarine. So a different problem that I'm happy to discuss later on another day is how do we get rid of the submarine? But at the low end of this gap is devices like the Hydromoth, which are extremely accessible, but their audio is inconsistent and they aren't designed for deep deployments. On the other end, you have sound traps, which produce fairly good data, but they are around $4,500 a piece and mainly not accessible for a lot of these conservation projects. And so there's a clear gap that I think FinDrop addresses, which is that there's no affordable and reliable solution for deep reefs. And so to fill that gap, here's the prototype version of FinDrop and currently beta version. But we developed a new acoustic recording system using capacitance-based arrays of MEMS microphones versus the traditional piezoelectric element. So the design reduces cost while producing a more consistent and accurate representation of the reef soundscape. And we successfully so far tested it to 200 meters, which opens up deeper reef monitoring, or even just simply a denser array network for your conservation project in shallow waters. So getting the system to work wasn't exactly straightforward, and this resulted in a number of prototypes. This was the first prototype I made 2 years ago in an aluminum can and a little homemade battery pack. I then went on to test hundreds and I think hundreds of different MEMS designs and communication protocols with the prototype PCB we were working with. And a lot of prototypes got really crazy and weird, and they just didn't work. So when we were out in Curacao, you don't have options for like a hardware store or things like that. And so you're left to limited devices like this. We needed some mineral oil. So all we could find was this Princess baby oil to submerge our MEMS into. Little to say, it wasn't very successful. And a lot of the prototyping kind of took unique innovations while out in the field. So like ripped up paper, pizza boxes and electrical tape and zip ties. I think we're all familiar. But the result of the system is that it produced a much clearer and more consistent signal compared to the lower cost devices. You can see Hydromoth on the left and the FinDrop on the right. And I think it should play. So you should be hearing a dolphin in the background, the damselfish croaking, and just the sound of a coral reef. And so by lowering the cost and increasing the accessibility, the system made it possible to start scaling acoustic monitoring across mesophotic reefs. And so in Curacao, we're deploying a dense network of about 30 of them over a 2-kilometer stretch. And so the power of going from 6 to 30 recorders allows long-term data on fish communities, improved understanding of reef ecosystems, and more improved conservation strategies. So in short, it's a tool that opens up research possibilities that weren't previously out of reach, both in deep reefs, but also any aquatic environment wanting to do biodiversity monitoring and conservation. And so as such, about 15 of these devices are deployed or being deployed around the world with select pilot partners. And we're continuously formulating them so to make FinDrop more accessible. But later this year, we hope to have a commercial product. And so this is for a number of different animals and organisms, not just fish. And so I'd like to thank the partners, obviously. And if you want more information than what I could provide in the speed talk, I do have a GitHub, and you're welcome to check that out. So thank you.
Wow, amazing. Thank you so much. Yeah, fantastic. Thanks for making such an interactive and interesting presentation. And yeah, all the audio worked really well, and it was nice to hear some dolphins. Yeah, it's really great to see a project looking to make, deep marine like bioacoustics more affordable, because as you say, there aren't too many conservation programs who can afford submarines. And I think following your project also really opened my eyes to some of the challenges, shall we say, that saltwater and extreme pressure can impose on tech. So yeah, it's been really great to see kind of the approach approved throughout the project. And it's really exciting that you plan to launch it as a commercial product soon as well. Do we have any questions for Matthew? Okay, I have a very quick question. So once you do launch it as a commercial product, where will it be available, and what comes next? Like, what are the kind of long-term plans for FinDrop?
Yeah, totally. So FinDrop will be available on Fisheye Collaborative's website. It'll just be like a Shopify account, and you can click and purchase however many you want. Currently, we're working with a number of projects using that just want to put it into a budget for their proposals, which is a great avenue if you want to have a competitive edge over other projects that might have more expensive hydrophones. But yeah. Well, thank you, Henry, for having me. It was great giving a talk. So
it's a pleasure. And please, any more questions for Matthew, please write them in the chat, or I'm sure you can reach out to us for his email and we can help set up some communication there. Thank you so much. Those were our 3 short talks from WILDLABS funded projects. And yeah, just really fantastic to see the work that they've done. But yeah, thank you. That takes us into our ad break. So I'm now going to hand over to my colleague, Carly, who I believe is here. Carly, are you with us on the call?
Hello.
Share the screen. Okay, you should see our ad break screen. Carly, please take it away.
Highlights and things to note happening in the WILDLABS community of late. So we recently, last month, had the first ever International Conservation Technology Conference, which was an incredible event bringing 600 people together from the conservation tech community. Next slide, Henry. And we're really happy to say that participants found it to be a really amazing event, as good as we were hoping it to be. And so really emphasizing developing new relationships, strengthening existing ones, identifying new tools, sharing knowledge, interactive sessions and workshops. So we're currently going through all of the survey data to kind of understand how we can make an even better ICTC in the future. So we'll be sharing more about this on the WILDLABS platform to come. But for those who are on the call who were there, thank you so much for coming and your amazing energy and information and knowledge. And for those who were not, stay tuned for more kind of opportunities to engage in shaping future in-person events. Another recent thing, we just closed the 2026 WILDLABS Awards call for expressions of interest. And so some quick stats about what we received. For those of you who submitted applications, thank you so much. Henry, next. We got 520 total applications. Over half of the project leads were from the Global South, which we're really excited to see. And the proposed projects would take place in a number of different countries, including some of the ones listed here, but we were really excited to see that 30% of the submissions said that they had a global or multi-country scope, cross-boundary work, global initiatives, and integrated kind of community, which is awesome. Good gender representation across project leads as well, which is awesome. and then the breakdown of the three kind of focus areas. So almost half of the submissions are about technology adoption and application, 30% on fostering innovation, and 20% on usability and scaling. So our team is currently reviewing all those expressions of interest right now, and we'll invite qualifying applicants to submit full proposals in April. So if you did submit an application, you'll find out in next month about the outcome of it.
Right, that's really, really, really exciting to see. And again, thank you so much to everyone in the community and everyone on this call, especially who applied and shared the opportunity. We got a really, really strong turnout this year, and we will be in touch soon with next steps for those qualifying projects.
One more quick highlight. We're celebrating 1 year of WILDLABS courses. So we launched this new kind of learning platform about a year ago with support from ARM and in partnership with Octafin Digital to have a course catalog, some that we developed ourselves, others that were external resources, that learning resources that we can link to. And it's really meant to be a community sort of solicited learning resource. So we now have 19 courses across 15 different topics. There's been 800 enrollments with a almost 60% completion rate, which is for those invested in pedagogy is quite good for online learning. So really encourage everyone to explore the courses. We'll put the link to the course catalog in the chat. And if you know of existing kind of courses or materials and want to incorporate them into the WILDLABS course catalog, please reach out to us to do that. We want this to be sort of a continuously growing platform.
Thank you very much, Carly. So now we can move into our regular quiz, which I have the pleasure of running. Usually the quiz is related to the talks and the theme, but the quiz today actually isn't related at all, but I recently did it myself and I thought it was so good that I had to share it with you guys. So it's completely unrelated. The quiz is very unrelated. It is moth, mushroom, or metal band. Basically, that probably sounds very strange, but there's a lot of overlap between the names of moth, mushrooms, and metal bands. They're all very doom and gloom, so it's really hard to tell which one is which just based on the name. So this quiz will be a bit different from usual. I'll show you some words on the screen, and all you need to do is write in the chat if you think it is a moth, a mushroom, or a metal band, and you can keep a record of your score if you want. But I think let's crack on with it. So, first one, Devil's Fingers. Is this a moth, a mushroom, or a metal band? And if you ask me, it could be any of them. Okay, we've got mushroom, mushroom, mushroom. Lots of mushrooms in the chat. Okay, I think that means everyone knows it's a mushroom. Is it a mushroom? It is in fact a mushroom. Well done, everyone that knew. The first one was an easy one, by the way. Okay, number 2, tomb mold. Moth, mushroom, or metal band? Moth, band. Couple of mushrooms. All right, good. We've got all three. This means that it is difficult. Moth band. I can tell you that the answer is metal band. Who mold the metal band? I haven't heard them, but I assume they're very good. Please check out Who Mold when you get the chance. Okay, number 3, bleached pig. Quite a concerning name, but is it a moth, a mushroom, or a metal band? Moth, mushroom. What do we think? Moth. The answer is moth. We have our first moth, the bleached pig moth. I don't know who named it, but it's a very strange one. Okay, weeping toothcrush. Moth, mushroom, or metal band? Mushroom. Couple of moths. Metal band. I can confirm it is a mushroom. There we go. Weeping toothcrush. That one I thought sounded a bit mushroomy. Black moth. Moth, mushroom, or metal band? I mean, it's obvious, right? Metal band, moth band. Adrian says it feels like a metal band. It is in fact a metal band. Yay, well done. That was a trick question. I bet there's someone in the chat that's listened to all of these bands and they know which ones are the best. Please tell us which ones are the best if you have. Confused. Moth, mushroom, or metal band? metal band, moth, a couple of moth, mostly bands. Sounds like a moth. The answer is moth. Someone has named this a moth the confused, which is pretty derogatory if you ask me, but anyway. And that's it. That is moth, mushroom, or metal band. There are many, many more. So we could have made this quiz maybe 50 questions long, but I think you guys get the idea. Please take this idea away and run it with your friends. It always goes down well. And I can send you a big list if you ever want it. But yes, thank you so much for participating in the quiz. If you did well, if you got them all right, please post in the chat. And if you can recommend the bands, please also tell us in the chat. But in the interest of time, I'm going to stop sharing my screen and I'm going to hand over to our final speakers of the day. So Francesca and Peter, I know, Peter, you've got your screen, your camera on, so please do go ahead, share your screens, and yeah, looking forward to hearing your talk.
Hi, everyone. The first 3-4 minutes introductory talk. We organized a session at the Conservation Technology Conference, Bridging Biologging and Stationary Passive Environmental Sensors for Conservation, which is a long expression to say bridging biologging with camera trapping and audio sensors, essentially, having especially terrestrial systems in mind. And we were really excited to try and bring all these different streams together for several reasons. Okay, which hopefully we can see, right? But we immediately identified the fact that this would be first and foremost a data problem. So when we say that we need to have these streams of information coming all together, it means that we have to deal with data, and we have to understand what data, what metadata they are, and how we can put them together for a certain reason. What the reason is, I'm sure is clear to everyone on this call, because biodiversity data must be available to the community, and they are not the end of the journey, rather the beginning, since we need to urgently close the science to policy link to estimate indicators for essential biodiversity values, ecosystem services. And we also know that within this community, and particularly the Wild Labs, a lot of effort is given to indeed support this link. Last but not least, the emergence of MoveOn. And for this very reason, it is nice to delve a bit into the diversity of data, some of which have been excellently presented today. First of all, movement data. We had wonderful bats moving around. I was so much impressed. Then camera trapping, which is also in a huge vibe, and audio sensors. We saw some excellent examples too from underwater. The question that we should ask ourselves is, with all such data actually produced, are they indeed used and preserved for conservation? Indeed, the data are expensive to collect, but they are not so often used beyond their project scope, even less at a global scale. And one of the reasons is that they are hard to find or they're not published, and therefore they are rarely included as indicators for EBVs, or even unknown. That most EBVs do not even consider, for example, movement, which is one of the very reasons why MoveOn started to emerge as something innovatory. And to sum up, they are rarely integrated, combined, and multiplied. I will give 2 quick points about biologging data. We have worked for a long time together with Sarah Davidson and others on the pathway that the biologging data should take to be in the sweet spot of being shared in the community and used for conservation. Of course, the first, the baseline is that data should be fair and respect trust. but also there is a series of steps that we could consider. So for example, first of all, the fact that data are likely to be ingested by repositories that are made to consistently support them. And the second relevant point that was already made a few years ago is that data and metadata should be really kept tightly together, because data without metadata doesn't mean anything. It's just a random picture or a random audio clip. And finally, when data and metadata are kept together, it is possible to translate them into products that should be, that's what we said in this early paper, easily discoverable through a global search engine acting as a meta repository. So this was like envisioned a few years back. Sorry, I just take 1 second to advertise the International Biological Society. It's free. Please sign up. We co-manage the animal movement group in the Wild Labs, and we have brand new social media, and we will have our great symposium next year. End of the advertisement. We go now to the second working example, this time talking about camera trapping. As we know, camera trapping and similarly also audio sensors have very different steps that go from picture management, so the actual management of the media, the storing of the media, the identification or classification of the actual biological content of the media, which should then managed in terms of information, hopefully according to data standards, and then should be made accessible in repositories. But then when we have these repeated multiple times, for example, for different repositories, for different streams and initiatives, how can we take everything together? And a few years back, we asked ourselves what would be the barriers for this to happen. The first barrier are data standards, so that we talk the same language, and luckily this really happens already in camera trapping thanks to CamTrapDP, the data standard for camera trapping data. But the second barrier that we have identified talking a couple of years back was the possibility to really put data together, like make data visible and accessible on some sort of a platform, like an inventory of projects. And so why am I offering these two examples, is to show that we have been talking for several years about biologging data streams, camera trapping data streams, envisioning that we needed data standards, but data and metadata tied up together, but also the possibility to have a place where to access studies that should be accessible for the several purposes, and in particular conservation. And so now, after this introduction, I'll give the word to Peter to say that maybe we actually got there. Mainly Peter got there. So thank you very much. And Peter, the floor is yours.
Thanks. So I'll skip to the introduction that Francesca wonderfully did. And so, as she said, so for animal tracking and also for camera trapping, we have both data management platforms, data standards are coming, and we have publishing tools to get the data out there. So this is for animal tracking and for camera trapping. And what we now have and what we want to introduce are two new data portals, WILDMoves, which is an animal tracking data portal, and WILDALBUM, which is a camera trap data portal. So these are not websites where you put new data or you publish your data. This is really websites that connects to published data sets already out there and give you a discovery tool to be able to find data that's already out there. So it's not reinventing the wheel or not yet another repository for data. It is trying to connect all these initiatives that already exist so you can discover data sets. And these two portals have a couple of features. There's a dataset search, which allows you to do a full text search, and you can filter by country, publisher, project ID. There's also for each dataset, there's a dataset page where you can find all that metadata about a single study or dataset. There's also metrics you can find if the data are attached, so you can see when were data collected, where were data collected. There's a citation mechanism where you can see how these data sets were cited and where they were cited. You can link back to the source data if the source data are available in the original platform where they are published. And you can also download the data directly from these dataset pages. Even cooler is that there is a search available across these data sets. So on the top, you see an image search for wild album, and on the bottom, you see a map of all the data across these data sets on Wild Moves. And again, you are able to filter across these data sets on scientific name, country, date, publisher, and show them in different way, either as a table or as images. And for your filter data, you're also able to download that subset of the data. These two websites were created by a team of volunteers and were also translated in Spanish by Claudia Meneses. And they are hosted by WildLabs. So thanks WildLabs for hosting these to have a bit of a branding and a permanent home. They were originally an idea from several projects, Big Picture, which is a European project on camera trapping, and also in MoveBon, it was suggested, hey, we should really publish more of these animal tracking data sets so they can be used in EBVs. But these two data portals are now the first visible outputs where you can see those data sets pop up. And most of the functionality is provided by GBIF. So the way it works is you can publish your data to GBIF. GBIF is the general database for all biodiversity data. It's an intergovernmental initiative, provides free and open access data, open access to biodiversity data. And you also have national help desk and really well-embedded national nodes often to help you publish data to GBIF. So the question then is, well, how can I include my data in these two portals? And in blue, you will see it for the animal tracking data, and in orange for the camera trap data. And the way it works is you publish your data set to GBIF as you would normally do with any biodiversity data that you can publish, and you can use the regular publication mechanisms for that. And then Wild Moves and Wild Album basically use a filter to select camera trapping data or animal tracking data, and then show only those data on the more dedicated website that you now have in Wild Moves and Wild Album. So that means, for example, Lucia, your bat tracking data that you have, if you have it on MoveBank, and you would republish or export that to GBIF, and we're working with MoveBank that can happen semi-automatically, so it's not on the researcher to do all that work, then it would automatically appear on Wild Moves. And the same, Matt, for you, even though it's audio data, we're planning to extend the CamTrap DP format that is used for camera trapping data sets to acoustic data. That would mean that your acoustic data set would also pop up on Wild Album, which is why we chose album, so it can apply to both images and sounds. So your data sets would end up there automatically. There are current limitations, so this is based on GBIF infrastructure. So we are parsing and crunching the data to Darwin Core, which is the general standard used by GBIF, and the same for the metadata. So some very specific filters that we would want, like filtering on sampling protocol, or is the source data available or not, or a better visualization of tracks that is not there. But it is a great discovery mechanism to find data across a whole number of source management systems. And we currently also don't have capacity or funding to really develop new features. We want to put it out there, so it's a bit of a place where people can discover, and also to encourage people to publish their data to GBIF, which then makes it widely available to many, many users, and it can be included in essential biodiversity variables or conservation efforts, but it would also end up on one of these two portals. So the way you can get involved now is really spreading the news, like, hey, these two websites exist, and maybe write project proposals to publish more data to GBIF or work on the data standards or best practice guides. This is really the first step it's the end step of the publication flow. And the thing I really like about that, if the data set end up in one of these two portals, it means a lot of things have gone right, as in the data are well formatted, people were fine with having this data be available, it went through the publication steps, it has a DOI. So it's really the star that you get for getting it all the way to the end. And we're working with many initiatives to make this process a lot easier. So it really becomes a tool where, for example, in MoveBon, we set the aim of let's try and publish at least 1,000 animal tracking data sets and see where we get from there. So thank you.
Thank you so much. It's amazing, super exciting that this is launched. And we've got a comment and a question in the chat. First comment is from Daniela asking, we would like to have a copy also. So please, connect with Daniela over that. And we've also got a question from Katie. Would data producers be able to track the studies that have downloaded or users publications of the data they shared into Move's albums?
Yes, so that is something that JBIF does automatically. Anytime you use the data from JBIF, you download data. That download gets a DOI, and if you cite that DOI as in that is the data I used, it automatically tracks back to all the data sets that have contributed to this download. So on any dataset page that you go to on JBIF right now, you will be able to see the number of citations, and then you can break it down on like how many peer-reviewed papers, how many reports. They do really a huge job because it is semi-automatically collected, all the citations of those DOIs of GPF download data. So yeah, they do that.
Fantastic, thank you very much. Do we have any more questions for Peter and Francesca?
Maybe while we wait, if I can add something, and Peter can always technically correct me. As he has explained, we can trace back to the identification for example, MoveBank, so that every time the data set is cited, is always possible to also reconstruct the original, the trace back the original data set, which is also very relevant. And this is not possible for all platforms, it's always possible for GPF at the moment, but it's working. Yeah, it is there, and we know it's one of the very cool points that as we move forward.
Fantastic. And I see Peter's added an example into the chat.
Peter, will you answer the comment?
Sorry, on bioacoustics. Yeah, so that is one of the submissions of the 520 submissions to WildLab Awards is to extend ChemTrapDB to bioacoustics data. This is something there's a lot of interest in the bioacoustics community to really also have a simple format to exchange data. So we hope to do that. And that means that all the publishing tools that exist for the ChemTrapDB standard can then immediately be used for acoustic data, meaning they would also end up on WildAlbum automatically. So the nice thing with these two portals is we can now leave our hands off because it will grow automatically by publishing data to GBIF. So yeah, there can be a lot of separate projects all contributing, all working in parallel and contributing to the same goal.
Fantastic. Lots of good stuff coming in the future then. Any more questions before we wrap up? We've got enough time on the main call for maybe one more question. Okay, it looks like we might be good then. Well, thank you very much. I would like to thank all of our excellent speakers today, Izabela, Lucia, Matthew, Francesca, and Peter. Thank you very much for making this such an interesting and super diverse variety hour. Please, thanks Robin for the applause. And please add any thank yous in the chat as well. Thank you very much from me too for joining. I've been your host, Henry, and I look forward to seeing you at the next one. Well, we might do an improved version of the quiz, as my colleagues have told me that actually I should have included pictures, which is a great idea. So come back for a new and improved moth metal band or mushroom with pictures. But thank you so much, everyone.